All right, guys, welcome to this page of the notes, and what we're going to do is we're going to continue with this idea of using the exponential properties of logarithms to go ahead and approximate the value of a logarithm. And again, I know you could use your calculator to find it. That's a great way to check your answer, but if you're taking this class with me, this is going to be a free response question, and it's actually your work that's worth the points available for the problem, not necessarily the correct final answer. So here we go. We've done one of these already. We'll just jump right into this and fly through the next couple. And of course, feel free to work ahead and then just come back and check your answers once you get done. I know that the log base 4 of 2, not approximately, it is equal to 0.5. And because it's a log base 4, I also know that the log base 4 of 4 is going to be equal to 1. So equipped with that information, let's go ahead and see what we can do with log base 4 of 32. Well, I know that log base 4 of 32, since you were given a log base 4 of 2, you know that 32 has to be divisible by 2. Even if I hadn't given you that, you know 32 is divisible by 2. So I can break that up into a log base 4 of 2 times 16. But now because I have a product in here, I'm going to use the product property of exponentials for logarithms to split it up into addition. Log base 4 of 2 plus log base 4 of 16, right? That's the product property for logarithms. Well, log base 4 of 2, I know. Log base 4 of 16, I don't know that. However, I do know 16 is a 4 squared. Sorry. And once I rewrite that 16 as a 4 squared, I should immediately recognize, hey, that's my power property for exponential functions, or exponential logarithmic functions. So I'll just drop that 2 out front as a coefficient. Log base 4 of 2 plus 2 times log base 4 of 4. And so here's what I wind up with. I know log base 4 of 2 is 0.5 plus 2, and I know that the log base 4 of 4 is a 1. So I have 0.5 plus 2, or 2.5 is going to be my approximation. And again, you can check your solution by just plugging log base 4 of 32 into your calculator, and you'll indeed get 2.5. Let's do a couple more. All right. First, let's real quick write down what we know. What I know is that the log base 2 of 5 is approximately 2.3219. That means I also know that the log base 2 of 2 is going to be equal to 1. And using that information, we're going to go ahead and simplify using the property, or simplify. We're going to go ahead and expand the log base 2 of 25 using the exponential properties of logarithms. And again, right away, since I've been given something with a 5 in it, well, pretty easily, right, you know that it's 5 times 5, or a 5 squared. I'll write it as 5 squared. Log base 2 of 5 squared. And this is the power property. That 2 will drop down out front. 2 times the log base 2 of 5. Well, I was given the log base 2 of 5, so I'll know it'll be 2 times 2.3219, which actually, sorry, I got a calculator right here. 2 times 2.3219, 4.6438. And again, if you wanted to, you could just throw that into your calculator to double check your work and make sure that you got it right, but we did it. We did it. Let's do another one. Quickly write down what you know. I know that the log base 3 of 7 is approximately 1.7712, which means then that the log base 3 of 3 is going to be 1. Using that information, we're going to go ahead and approximate the value of log base 3 of 49. Well, I know 49 is a 7 times 7. You could just as easily do a 7 squared. It'd be exactly like the one we just did. This time I'll do 7 times 7, in which case I'll then use the product, the product property for the exponential product property for logarithms to split it up into addition. Which means I wind up with 1.7712 plus 1.7712. Since I know the log base 3 of 7, it was given to me, and log base 3 of 7, it was given to me. You go ahead, add those guys together. I got a calculator right here. Let's see what we get. Should get 3.5424 as your answer. Again, you can certainly just double check that by plugging log base 3 of 49 into your calculator. It's a great way to check it, but again, if you're taking this class with me, these will be free response questions, and I'm looking for that work. Can you show me that you know how to use those exponential properties of logarithms to split this guy up? All right, guys, head on over to the next page of the notes. We'll take a look at a couple more word problems dealing with logarithmic formulas and equations. So head on over there, and I'll meet you guys over there.